Good afternoon, class. This is Econ 510 Managerial Economics class. Today is January 27, Thursday. So we will review chapter 1 through 3 in order to prepare for the next week's first midterm exam. In chapter 1, we discussed the overview of macroeconomics, and also we discussed the production participatory frontier and comparative advantage in chapter 1. And chapter 2, we discussed the demand and supply and market equilibrium. In chapter 3, we discussed the elasticity analysis, and also we analyzed elasticity using the linear regression model. So we will watch some summary of each chapter to prepare for the first midterm exam. But remember that this summary video is not enough to cover all 3 chapters. You have to read the textbook for each chapter and watch the video clips I posted, and also you have to study with my PowerPoint as well as your book chapter. So let's start with chapter 1.
We've said that economics is the study of rational choice in the face of scarcity. Let's talk now about what it means for economics to be a study. Economics is called a social science or a behavioral science. And as a science, economics is a disciplined way of thinking through problems. The scientific method is a tried and true way for knowledge to accumulate, to ask questions, to craft explanations, and to come up with ways of testing those explanations against what's going on in the real world. So economics, as a science, uses the scientific method to understand the way the world works. The scientific method begins with a question. That is, all science begins with curiosity about the way the world works. If you want to be a scientist, you should develop the habit of curiosity. That is, asking the question why at least 3 times a day. You drive through a little town and you wonder, why are all the gas stations clustered on the 4 corners of the main intersection? Or you go to the grocery store and you wonder, why are there 150 different kinds of breakfast cereal? And yet there are only really 3 categories: cereal that tastes like fruit, cereal that tastes like chocolate, and cereal that's good for you. Why? 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 Ask the question why, and you're training your mind to be scientific and preparing yourself to be sharper and more flexible. Economics really asks 3 questions over and over again. The first question is, what should we produce? That is, what are we going to produce of all the possible baskets and bundles and combinations of goods and services that we can create in our economy? What combination of houses and cars and clothes and vacations and medical care are we going to create out of our limited resources? The second question is, how will it be produced? That is, how will we combine labor and capital and raw materials to create the goods and services that satisfy our needs and wants? And the third question is, who is going to get it? That is, how will these goods and services be divided among all of the people in the economy, each of whom wants more? What will we produce? How will it be produced? And who will get it? These are the questions that economics asks. Economics also asks more specific questions about each of these general categories, such as, what would happen if we imposed a minimum wage law on the labor market? Would it create unemployment? Would it increase the wealth of workers? What would be the consequence? We're asking a question here, and that's the beginning of science. What would happen if consumer income increases? Would it lead to more spending, or more saving, or something else? Ask the question, and the next thing you know, you'll find yourself at the second step of the scientific method. That is, you'll be building a model. What is an economic model? What is a scientific model? A model really is nothing more than a map. Think for a moment about the way a map works. You begin with a question. How do I get from the theater district to the Metropolitan Museum if I'm in New York City? Well, that answer is going to depend on the method of transportation that you choose. If you want to know how I would find the best walking route, that is, which streets should I take and can I cut through Central Park, you're going to want to use this map. It's a street map of New York City that has the parks and restaurants and theaters and museums right here in different colors. On the other hand, if you're planning to take the subway from the theater district and find out how close you can get to the Metropolitan Museum, you'll want to use this inset map, which instead of the streets focuses on the subway routes, each of them being color-coded. The map that you want to choose depends on the question that you originally asked. If you're going to be riding the subway and your question is, which subway should I take? You don't need a map that has a lot of streets on it. You want all that detail cut away so that you can clearly see the subway routes. On the other hand, if you're going to be above ground walking on the streets, you don't care what's underneath you. The subway routes are irrelevant and would only add clutter to this picture. So a good map is one that includes enough information to help you answer your question, without irrelevant information that would only distract you and clutter the picture. The same is true with a model. If we want to ask ourselves, what is it that determines the amount of money that households spend on consumer goods and services each year? What determines consumer spending, and when does it rise and when does it fall? We're going to want to build a relationship between consumer spending and other variables that influence it. We're going to be looking for those variables that probably have the most direct impact on the consumer's choice to spend or save money, and to ignore the rest. So as we're building this model, we're going to want to include things like consumer income, taxes, the stock market, and other factors that influence how much money people choose to spend. We can probably ignore other things that bear less on the consumer spending decision, such as the gender of the children or the color of the breadwinner's hair. I mean, these are real facts from the real world, but they probably aren't very important in determining how much money people spend. Margaret Mead once said that a model that is completely realistic is no more useful than a map with a scale of 1 to 1. That is, the only reason the map helps you is that it's simple enough and simplified enough to help you see the big picture and the details that are necessary in helping you guide your way through the city. On a typical map, you won't see trees and dogs and cars because they're not necessary. And by eliminating them and showing you the grid of the streets, you are helped in navigating your way around New York. So we build a model, and perhaps that model is a story whereby people make spending decisions based on their income, their taxes, and their age. People who are younger tend to spend more, then save more in their middle years, and spend it in retirement. And we build a relationship among these variables, and that becomes our model of how consumers make their spending decisions. Now, once we've got a model, the relationships that we imagine hold among the variables allow us to derive certain hypotheses. Hypotheses are predictions about the way the world works. One hypothesis might be that an increase in consumer income leads to an increase in consumer spending. Now, that hypothesis is something we can test. We can go out and get data from the real world and compare the relationship between observed consumer income changes and changes in consumer spending. And if our data matches the predictions of our model, then we believe that we've explained something about the real world. We believe that since our story matches the facts, we've come to understand more thoroughly the way the world works. This is the scientific method. Ask a question, isolate the variables that are related and important and build a model, and then come up with some predictions or hypotheses that you can test against the data in the real world. And when that happens, you're doing science. Now, one of the things that helps you be a careful and disciplined scientist is looking at these changes in a careful way that is trying to isolate the variables from one another and looking at the effect of one variable while holding the other variables constant. For instance, we want to know what happens to consumer spending when consumer income changes. And we're trying to predict a relationship between income and consumption that will explain something about the way the world works. Well, if we want to do that, we need to hold constant the other factors that influence consumer spending decisions. So if we hold taxes constant, my pink bar here over the T means that I'm holding taxes constant. And we look at consumers of a particular age, so that we hold age and demographic factors constant, then what's the relationship between income and consumer spending? And perhaps we predict in our model that if you increase income and hold everything else constant, consumer spending will also increase. This assumption that we're holding everything else constant has a name. That assumption is called ceteris paribus. And the question that we ask is, what will happen to consumer spending if we increase consumer income ceteris paribus? That is, holding constant all of the other variables that also influence consumption decisions. So, whenever you hear me use the term ceteris paribus, what I'm doing is I'm isolating a variable. I'm saying, what will happen to consumption when income increases? Let's focus on income and hold everything else constant. That's what ceteris paribus means. So you're training now to be an economist. You're training to use the scientific method in order to answer questions about the way the world works. So what are you going to do with this training once you've sharpened these skills? Well, you can find economists in all walks of life. Economists show up in business, they show up in government, and they show up in academics. In business, economists make forecasts about what's going to happen to interest rates and consumer spending and housing starts. They look at the big picture and help to advise the people who are making decisions in corporations about when to launch a new product and when to expand their operations and into which countries. In government, you find economists doing research, collecting data, figuring out how to finance the government debt, when to impose new taxes, and looking at broadly at what's happening in the economy to consumer spending, business spending, and imports and exports. And finally, in academics, not only do you find people who are teaching your economics classes, you also find high-caliber researchers who hold academic positions in research universities. They are supported to do research and answer questions like what will happen when a minimum wage is imposed, or what's the relationship between income and consumption, or what's the effect of tariffs and quotas on the flow of international trade. Economists show up in business, government, and academics. And as you train to be an economist, you'll find that you can use these tools even if your title isn't economist, because these logical, scientific ways of thinking pay off in all kinds of lines of business. There's one more thing to say about economics as a study, and that is that we want to make a careful distinction between positive economics on one hand and normative economics on the other. Positive economics is economics as a predictive, descriptive social science. Positive economics seeks to answer the question, how does the world work? What is going on? Whenever we do positive economics, we're making observations. We're asking questions like, what will happen when a minimum wage law is imposed on the labor market? Will we see unemployment? Will we see an increase in wealth? Positive economics answers the question, what will happen in the bread market if we impose a tax on the sales of bread? Positive economics answers questions about the way the world works, what is, predictions, and descriptions. On the other hand, normative economics is about making judgments or evaluations. Normative economics answers the question, how should the world work? What is a good outcome? Normative economics answers the question, should we have a minimum wage law at all? Or is there a better way to provide for low-income workers, perhaps an earned income tax credit or some other policy? Normative economics is about norms, and norms are standards of judgment. What is good, what is better, and what is bad? Whenever we're doing normative economics, we're seeking to come up with the best policy for a particular situation. Should the government pay off the national debt? Should we have a tax on gasoline or cigarettes? Normative economics answers the question, what is good? Now, of course, if you're going to want to make judgments about the way the world should work, you'd probably better have a pretty good understanding about the way the world actually does work. That is, if you want to build a garden that you think is beautiful, you need to know a lot about the way plants grow and which ones respond to sunlight and which ones respond to fertilizer. You need to understand the structure of the economy before you start saying what it is that the government ought to do or what it is that corporations should be allowed or prohibited from doing. To make judgments, you should have an understanding of the structure of the relationships in the economy. So positive economics and normative economics are very closely related. So, if you want to be an economist, you'll be using the scientific method to describe and make predictions, and eventually make recommendations about what kind of policies help lead to good outcomes. We've been looking at linear relationships between variables and how economists think about these. So far, everything that we've looked at has had a constant slope. That is, we've been analyzing straight line relationships, such as the relationship between price and quantity in Bob's demand for hamburgers. Now we're going to look at a relationship that is not linear. In fact, it's what we call curvilinear. It is a line that's not straight. We're going to see how we draw a relationship like that and how we calculate the slope of a relationship where the slope is not constant. In order to do that, let's look at the relationship between labor and output for a firm that makes television sets. And I've made up these numbers so that I can fit a curvilinear line to them. Here is my relationship. If you have one worker working by himself, he can make a single television in a day. If you have two workers cooperating, they can make 4 televisions in a day. If you have 3 workers, 9, 4 workers, 16, 5 workers can make 25 televisions, and so forth. Now, notice this relationship is one of exponential increase. That is, the number of TVs are increasing much faster than the number of workers. So in this case, our slope will not be constant. Let's represent this relationship now in a picture. I'm going to take my axes here and use the axes to represent the amount of labor that the firm uses. So we're going to measure labor on the horizontal axis. And on the vertical axis, we're going to measure output. And in this case, it's going to be output of television sets. So each point in this space will represent a combination of labor and output. This is a production relationship. So, for example, one worker is able to produce a single television if he's working by himself. So since I've calibrated these axes where each of my lines represents 2 TVs, my first dot will be halfway up towards this point at 1 worker and 1 television set. So here's my first point on my product curve. The second point on my product curve will be 2 workers and 4 television sets. So that's going to be at this point right here. 3 workers are able to produce 9 television sets, so that gives me a point like this. 4 workers are able to produce 16 television sets, so follow this line up here to 16. And 5 workers can produce 25 television sets, so follow this line all the way up to 25, which will be right here. Now, connecting these dots is going to be a little bit more complicated than connecting the dots in our earlier story. In the earlier story, all we had to do was pick any 2 points, draw a straight line between them, and we had a demand curve. But the production curve is not linear. That is, the slope is not constant, so I have to draw a curve that connects these points together. That curve is going to look something like this. Let me take a curve here and figure out how to make it fit. I want it to go through this point, and this point, and this point, and this point, and this point. And so my curve is going to look something like this. It's going to be an exponential relationship. So if I want to connect my dots I'm going to have them lying along a blue line that looks like this. Let me go ahead and draw that blue line in. I could have kept that curve there and just drawn along it, but I'm going to try, and it takes practice to do this well, to connect my blue dots along a single curved line. It's like this. Well, that's not bad. So I'll go ahead and make this line a little bit darker. And there's my production function for a firm that hires workers to produce television sets. And we might call this curve the total product curve. We'll be studying this later in the lectures. So I'll go ahead and label this TP, total product. And this total product curve depends on lots of things, like the technology of the firm and the size of their factory and other things. What I'm mainly interested in at this point, though, is figuring out what the slope of this curve is at a particular point. Say, for instance, we are looking at this point right here, the point where we're hiring 2 workers and making 4 television sets in a day. And I'd like to know, what is the slope of the curve at this point when I'm hiring 2 workers and making 4 television sets a day? What's the slope of the curve? That is, what's the rise over the run? How many extra television sets will I be able to produce if I hire an extra worker? Well, to calculate the slope of a straight line, it's not quite as simple as looking at 2 points on the curve. Because as you move from one point to another, what's happening is that the line itself is changing its slope. Down here, our blue curve is relatively flat. That is, if we look at a point down here, we get a relatively flat line. But as we move up the curve, notice, the line is getting steeper and steeper and steeper. The slope is changing all along this blue curve. So if we want to calculate the slope at a particular point, we can't just look at the slope between 2 points on the curve, because as you move from here to here, even that small movement represents a change in the slope, or causes a change in the slope of my total product curve. The blue curve slope is changing. Well, here's how we do this. We calculate the slope of a single point on this curve. We calculate the slope at a single point by taking the limit of slopes of lines that connect 2 points on the curve. So, for instance, suppose we look at what happens as we move from 2 workers to 4 workers. As we move from 2 workers to 4 workers, what happens is this. We're moving along a line that connects those 2 points. And the line that connects those 2 points is this line right here. This red line connects those 2 points. Now, what's the slope of that red line that connects this dot with this dot? What's the slope of that line? Well, let's calculate it. The slope of my red line here is equal to the rise over the run, or the change in the vertical axis variable, that is a change in the number of television sets, divided by the change in the number of workers. Well, the change in the number of television sets is going to be 16 minus 4, which is going to be equal to 12, and divide that by the change in the number of workers, which is going to be 4 minus 2, and that's going to give me a slope of 12 over 2 equals 6. The slope of this red line right here, that is its rise over its run, is going to be 6. The slope of that line is 6. However, if I took a different red line, say the red line that connects this dot to this one, its nearest neighbor, we're going to get a different slope. Let me go ahead and draw that. If I connect this dot with the nearest neighbor, my red line is going to be a bit flatter. Now, it's a little harder to see that line because it's almost right on top of the blue line. But what we've got here is a line that connects this dot with its nearest neighbor. I'd like to know what's its slope, what's the rise over the run as I move from this point to the next. So let's look then at the slope as we move from 2 workers to 3 workers. In that case, the slope once again is rise over the run, but the slope along this point is going to be a little bit different. The slope in that case is going to be equal to, the output has changed from 9, or to 9 from 4, divided by a change in workers from 2 to 3, gives a slope of 9 minus 4 is 5 over 1, which is going to be equal to 5. So the slope at this point is 5. Notice what's happening. As we move from this original red line that connected these 2 points to the red line that connects 2 closer points, the slope is getting flatter. It's gone from rise over run of 6 to rise over run of 5. Eventually what happens is if we let the point that we're looking at get closer and closer to our original point, if we let the point that we're looking at get closer and closer to our original point, we're eventually going to come up with a line that has a slope that is equal to the slope of the blue curve itself. Eventually what we get is what we call the tangent line. The tangent line is the line that just touches the blue curve. If you had something straight like this ruler and you wanted to lay it against the blue curve, laying the ruler against the blue curve would give you the tangent line. Laying something straight against a curved line at a particular point gives you the tangent. Tangent means touching. If you wanted to take the blue curve like before and lay it against the blue curve and have this blue curve be a straight line, the slope of this blue curve now is the slope of the tangent line, the line that just touches. So to calculate the slope of a curve at a particular point, you take the limit of the slope of the lines that connect that point to other points, and that limit is going to be the tangent line, the slope that's tangent. So when we're looking for the slope of a curved line, we take the slopes of lines that connect points on the curve, let those slopes change as the point gets closer and closer to the point we're interested in, and finally we come up with a line that's tangent to the curve at the point we care about. In this particular case, from calculus, I know that the tangent line that I've drawn here with a dash has a slope of 4. I'm not going to do the calculus right now, but what I'm interested in your understanding is that when you have a curved line, the slope of that line changes as you move along it. And the important thing for you to know that the slope of that curve at a particular point is the slope of a straight line that touches the curve at that point.
We've defined economics as the study of rational choice in situations of scarcity. In this lecture, we're going to take a closer look at the concept of scarcity and how economists describe scarcity. Scarcity means that you have a limited quantity of resources with which to satisfy potentially unlimited wants. But let's be more careful about that. What are those resources, and what can we do with them? How do we use our resources to create the goods and services that satisfy our desires? In order to represent the possibilities of an economy, we're going to introduce a tool, and that tool is the production possibilities curve. Now, we're going to be working towards that, but first, I want to introduce a concept that will be very important in this lecture and really throughout the course, and that's the concept of efficiency. Efficiency refers to doing the best you can with what you have, or making the largest quantity of output possible with your given quantity of inputs. Efficiency refers to getting the most you can out of what you have. So for instance, if we have a cook who is talented with lots of good recipes, and he has a lot of food in the kitchen to work with, and a good set of knives and other tools and a stove, efficient behavior would be using his talent and those resources to produce the most meals that he's capable of producing, getting the largest quantity of output from a given quantity of input. if he wastes some of the food, if he uses his time wastefully so that the quantity of output that goes out the door of his kitchen is less than is possible, then we say that his behavior is inefficient. Suppose we have an economy that produces two goods, and for the sake of our example, we'll make these an agricultural example. Our two goods are wheat and rice. So let's suppose we have an economy that produces these two products. Efficient behavior would be for the economy to produce the most wheat that it can possibly produce for a given quantity of rice. That is, using all of the resources that are left over that aren't producing rice and making the largest quantity of wheat possible. That's what we mean when we refer to efficiency, getting the most you can out of your limited quantity of resources. Now, I want to describe the production possibilities of a particular economy. This hypothetical economy produces only two goods, wheat and rice. Before I describe the production possibilities, you might want a little additional information. The first thing you're going to want to know is, well, what resources are available in this economy with which to produce these two grains? How much arable land is in this economy? Is the land wet or is it dry? What kind of labor is there in this economy? What kind of tools? Are there tractors and combines, or are there merely shovels and hoes? The first thing you need to know when you want to describe the production possibilities of an economy is, what is the resource endowment of that economy? How much land, labor, and capital does that economy have to work with? The second thing that you're going to want to know is, what are the capabilities of this economy given these resources? That is, what are the strategies this economy has for combining inputs to produce output? And we call that the economy's technology. When an economist refers to technology, the economist means a complete catalog of all the things this economy knows how to do, all the ways in which this economy can combine inputs to produce output. There are techniques that involve using shovels and hoes and low-skilled labor on particular kinds of land to produce rice or wheat. There are techniques that involve using tractors and combines and a different kind of land to produce rice and wheat. A technique is a particular combination of inputs, but a technology refers to all the possible combinations of resources that the economy can use to produce output. So when an economist refers to technology, the economist is referring to a catalog, a complete list of all the things the economy knows how to do. When your technology improves, it usually means that you're able to produce more output with less input because you're using that input in a smarter way. Now, given our knowledge of the economy's resources and what we know about the economy's technology, we're able to describe the production possibilities of the economy. And I'm going to do that first in this table. This table represents the production possibilities of our hypothetical economy. And every combination of numbers in this chart represents an efficient combination. That is, we're saying that if our economy uses its resources, all of them in the production of wheat, it can produce 80 bushels of wheat a year. Well, since all the resources are devoted to wheat production, there isn't going to be any rice production in this case. If the economy moves some of its resources into the production of rice, and let's suppose that it moves those resources that are best suited for rice production, the wet land, the workers who know more about rice production, tools that are well suited for the production of rice, the economy can produce 20 bushels of rice and still produce 78 bushels of wheat. Notice that the wheat production is decreasing as resources are moved into the production of rice. But since we're moving first those resources that are well suited for the production of rice, we can get a large increase in rice production for a small decrease in wheat production. Next, we can get an additional 20 bushels of rice per year if we reduce wheat production by 8 more bushels of wheat a year. The combination 70 and 40 is another efficient combination. That is, the maximum amount of wheat that we can get out of our economy when we're producing 40 bushels of rice is 70 bushels of wheat, if we're using all of the resources in the best uses possible and everyone is working as productively as they can. If we increase rice production to 60 bushels a year, wheat production falls to 55 bushels. And if we increase rice production to 80 bushels a year, then wheat production falls to 38. Finally, if we put all of the resources in our economy into the production of rice, we get 100 bushels of rice per year. And of course, no wheat, because all of the resources are devoted to rice production. So the production possibilities table represents those efficient combinations of rice and wheat production that are possible given the economy's technology and given its resource endowment. That is, for each number in the right-hand column, for each quantity of rice produced a year, the number in the left-hand column tells us the maximum quantity of wheat that this economy can produce, using its resources with efficiency. Now, I've got a production possibilities table here. I've got the combinations of wheat and rice that are possible to be produced in this economy. I'm going to now represent this information graphically. I'm going to put the production possibilities information into a diagram, and we're going to call this diagram the production possibilities curve, or the production possibilities frontier. First thing I need to do when I draw a diagram is make sure that I've carefully labeled the axes. So the first thing we'll do is we'll put wheat production on the vertical axis. That is, the number on the vertical axis refers to the quantity of wheat in bushels that's produced in this economy in a year. The next thing will be to label the horizontal axis, and we'll put rice production here. The number on the horizontal axis tells us the quantity of rice that's produced in this economy in a year. Now, next thing I want to do, since I'm going to be using real numbers, and I want to be careful about plotting this curve accurately, I want to calibrate the axes. I'll want to put some numbers in that tell me how things are measured on each axis. Let's use, since I'm going up to 80 bushels of wheat, let's make each hash mark on this axis equal to 20. So here's 20 bushels of wheat. Here's 40. Here's 60. And here's 80. And I can keep on going, but I'm calibrating the axis here with each hash mark representing 20 additional bushels of wheat. Same thing with rice here. I'll make this be 20, and this 40, and this 60, and here's 80, and finally 1. And of course, it keeps going. Now I've got my axes calibrated and labeled carefully, so I'm ready to draw my graph. And let's now take the numbers, which are now over on the board, and put them as points on a curve in this diagram. So the first combination of wheat and rice that's possible is all the resources devoted to wheat production. We produce 80 bushels of wheat and 0 rice. That gives us a point that's right here on the vertical axis. The next combination is 20 bushels of rice and 78 bushels of wheat. So we go over here to 20 bushels of rice and up to 78 bushels of wheat, and I put another point on the curve. If we produce 40 bushels of rice, then the maximum wheat production I can get out of my economy is 70. So there's another point on the curve. With 60 bushels of rice, I get 55 bushels of wheat. With 80 bushels of rice, I get 38 bushels of wheat. And finally, with 100 bushels of rice, my wheat production has been pushed down to 0 because all of the resources are devoted to the production of rice. So what I did was take the numbers from the production possibility schedule and put them in a diagram with wheat on the vertical axis and rice on the horizontal axis. Now, these are not the only combinations of wheat and rice that we can imagine. In fact, you can imagine our economy moving resources continually or continuously out of the production of wheat into the production of rice, so that the quantity of rice produced increases gradually as the quantity of wheat produced falls gradually. If we plotted all the possible points, they would lie between these blue points, and if I connected the dots, I would get a nice, smooth, continuous curve. And this curve is called the production possibilities curve, or the production possibilities frontier. The production possibilities frontier is defined thusly. The production possibilities frontier is a collection of points representing the maximum amount of wheat that can be produced for a given quantity of rice production. These points are all of the efficient combinations of wheat and rice that can be produced in the economy. For any point on this horizontal axis, you can go up to the blue curve and find the maximum amount of wheat that can be produced when the economy is producing this quantity of rice. That's the production possibilities curve. As we look at the production possibilities curve, we can see that there are many things represented in this picture that are very basic concepts in economics. The first thing that we notice whenever we look at this picture is that there are points that are outside the production possibilities frontier. There are points such as this one, where we have 80 bushels of wheat and 80 bushels of rice produced in a given year. This point would be a great point because it involves a lot of everything. However, this point is not attainable. This point reminds us that scarcity is a reality in this economy. Given the quantity of land, labor, and capital, given our resource endowment, and given the technology that's available to us in this economy, this point out here, we'll call this point S, because it represents scarcity. This point is unattainable. We simply can't get to it. There's no way to make this much wheat whenever we're making this much rice. So points that lie outside the production possibilities frontier represent a larger quantity of goods than this economy can possibly produce. They remind us of the reality of scarcity. Likewise, points that lie within the production possibilities frontier remind us of inefficiency. I'll call this point down here point U. Point U is certainly possible. It's always possible for us to produce points that are within the production possibilities frontier. But why would we want to? We would prefer to be up on the production possibilities frontier with more of everything. If more is better, we would always prefer a point on the blue curve to a point inside it. But these are the points that we wind up with when the economy uses its resources inefficiently. If the economy is not getting the maximum possible productive output from its resources, we're going to be inside this curve. That happens when some resources are unemployed, that is, if some of the land or labor is not used. It also happens if some of the resources are underemployed, that is, if resources are used in a way that is not maximizing their output. For instance, if we take wet land and use it to cultivate wheat, and dry land and use it to cultivate rice, we're going to wind up with less grain than we could produce. Because wet land is better for rice and dry land is better for wheat, we're going to wind up inside the production possibility frontier at a point of inefficiency, unemployment or underemployment of resources. Here's another thing to notice. The production possibilities curve is downward sloping. That means that as we increase production of rice, we are necessarily reducing the production of wheat. In order to produce additional bushels of rice, you have to give up wheat that you might otherwise have produced. That is, wheat is the opportunity cost of rice. Anytime you want to increase rice production, you're going to have to move resources out of the production of wheat. Land, labor, and capital that's used to produce wheat is transferred into the production of rice in order to increase rice production, and that means that wheat production will be decreasing. Wheat is the opportunity cost of rice. We can actually calculate this opportunity cost. Look, whenever we increase rice production from 0 to 20 bushels a year, wheat production is falling from 80 bushels to 78 bushels. The opportunity cost of the first 20 bushels of rice is 2 bushels of wheat. We can even calculate the opportunity cost per bushel of rice by doing a little calculation. First, let's calculate the change in wheat production. The change in wheat production is the new quantity of 78 minus the old quantity of 80 for a change in wheat production of -2, a loss of 2 bushels. The rice production is 20 minus the old quantity of 0, so the change in rice production is 20 bushels. 20 minus 0 equals 20. Now, divide the change in wheat production by the change in rice production, and you'll get -2 over 20, or -1/10. That is, for each additional bushel of rice that we are producing between 0 and 20, On average, we're giving up 1/10 of a bushel of wheat. 1/10 a bushel of wheat is the opportunity cost of each bushel of rice, on average, between 0 and 20. Notice something else, that if we draw a line connecting these 2 points, the original point of 80 and 0, and the new point of 78 bushels of wheat and 20 bushels of rice, if we draw a line connecting those 2 points, the slope of that line is going to be the change in wheat production divided by the change in rice production. Now remember, what's the formula for the slope of a line? The rise over the run. As we move between these 2 points, the rise is the change in wheat production. The rise is the change in the vertical coordinate. That is, we go from 80 to 78, -2. That's the rise. The run is the change in the horizontal coordinate. We go from 0 to 20. So that change of 20 is the run. -2 divided by 20 is the rise over the run. The change in wheat production divided by the change of rice production. And in this case, that number is -1/10. So I'll go ahead and put a little mark here indicating that I'm calculating the slope between those 2 points, and I'll make a note that it's -1/10. The slope of the production possibility frontier represents the opportunity cost of rice production, measured in terms of the wheat that we're giving up. As we move between these 2 points, each additional bushel of rice that we produce is costing us 1/10 of a bushel of wheat, on average. The slope of the production possibility frontier is the opportunity cost of rice production, measured in terms of wheat given up. We can calculate the slope down here as we move from 80 to 100 bushels of rice, and we'll find we get a different number. The change in wheat production is the movement from 38 bushels of wheat to 0 bushels of wheat. Take the new quantity of wheat, which is 0, subtract the old quantity, which is 38, and you get -38, a loss of 38 bushels of wheat. The change in rice production is 100, the new quantity, minus 80, the old quantity. That gives us 20 bushels of rice added. -38 divided by 20 reduces to -19 over 10, or -1.9. If I connect these 2 dots, the slope of this dotted black line is the rise over the run, the change in wheat production divided by the change in rice production. And this slope in this case is -19 over 10, or -1.9. That is, for each additional bushel of rice that we're adding between 8 and 100, on average, we're giving up almost 2 bushels of wheat for each additional bushel of rice. The opportunity cost is 1.9 bushels of wheat lost for every bushel of rice added. Notice the opportunity cost down here is much larger. Each additional bushel of rice costs almost 2 bushels of wheat. Up here, each additional bushel of rice costs only 1/10 of a bushel of wheat. The opportunity cost is changing as we move along the production possibility frontier. And you can tell by looking at it. The slope of the curve is pretty flat up here near the vertical axis. As we move down the curve, the slope gets steeper and steeper and steeper and steeper as we approach the horizontal axis. Remember, the slope of the production possibility frontier is the opportunity cost of producing rice, measured in terms of wheat that you give up. So down here, the opportunity cost is very high, whereas up here, the opportunity cost is relatively low. What does that tell us? Well, this is the final thing to notice about the production possibility frontier, is that the production possibility frontier is concave. That is, it bows outwards. The slope of the production possibility frontier is pretty flat near the top and pretty steep near the bottom. And the slope is decreasing. That is, the slope is becoming a larger and larger negative number. The curve is getting steeper as we move down it. What does that tell us? It tells us that the opportunity cost of producing rice is increasing. The more rice we produce, the more expensive it gets to make another bushel. Why? That's because not all resources are equally well suited for the production of wheat and rice. Some resources are very well suited to the production of rice. These resources include wet land, workers who know a lot about rice cultivation, particular types of tools that are well suited for tending rice. Some resources are better suited to the production of wheat. Those include dry land. They also include workers who know a lot about wheat production, fertilizers that are good for wheat, and so forth. When an economy has a scarce, strictly limited quantity of resources, some of them will be very well suited to the production of one good, others will be better suited to the production of the other good. In this case, when we first begin to produce rice, we're going to be using the wettest land and the workers that know the most about rice production. That wet land probably wasn't growing a lot of wheat. Therefore, when we first start to produce rice, we can do so with a small opportunity cost. Very little wheat is given up because that land wasn't very productive anyway for wheat. It was better suited for rice. But as we make more and more and more rice, we're using up all the land that's well suited for rice, and then eventually we have to draw on the land that's better suited for wheat, dry land, and workers who know more about wheat cultivation than they know about rice. That's when the opportunity cost starts to get very, very large. Down here, we have to move a lot of dry land out of the production of wheat just to get an additional 20 bushels of rice. And that's very costly in terms of the wheat that we lose. That's why the opportunity cost of rice production increases the more rice the economy chooses to produce. So, there you have it. 4 things about economics that you can tell by looking at a production possibilities frontier. First of all, you see that scarcity is a reality. Some combinations of wheat and rice are simply unattainable, given our technology and our resources. Next, notice that there are a lot of inefficient points. There are a lot of combinations of wheat and rice that aren't taking full advantage of the resources and technology that we have. Third, notice that the curve is downward sloping. That is, there's an opportunity cost. If you want to produce more rice, you have to give up wheat production. Once again, that's because of scarcity. And finally, the curve is concave. That is, the slope is getting steeper as we move down it. The curve gets steeper because the opportunity cost of rice production increases the more rice we make. This increasing opportunity cost is due to the fact that some resources are well suited to rice production and other resources are not. So this simple tool captures in it most of the basic ideas of economics: scarcity, efficiency, opportunity cost, the suitability of resources. In the next lesson, we'll look at how changes in resources and changes in technology affect the way this picture looks. In this lecture, we put together our previous analysis about supply and demand to come up with a model of the market. And the payoff is we have a way of predicting how factors in the environment will influence the price of a good and the quantity of that good traded. We're going to be developing a tool that economists use called the competitive equilibrium. The competitive equilibrium is what happens when you get together a bunch of buyers and sellers, all of whom believe that they have no influence over the price. That is, all of the agents in our market are price takers. They accept the market price as given and do the best they can subject to that price as a constraint. So the buyers take the price as given and choose their quantity demanded. The sellers take the price as given and choose their quantity supplied. When the price is such that the quantity supplied is equal to the quantity demanded, we say that we have a competitive equilibrium. Now, first we should define the concept of equilibrium in economics. An equilibrium is a situation from which there is no tendency to change. And as we will see in our model of supply and demand, there is only one price at which there is no pressure for something to change. Let's go back to the analysis that we've developed earlier. The red dots in this diagram represent quantities demanded at different prices. This information comes from the table that's over on the board. At a price of $5, the quantity demanded is 1 loaf of bread per week. At a price of $4 per loaf, the quantity demanded is 2 loaves per week, and so forth, giving us this collection of red dots. We could connect these red dots and form the demand curve, but we're going to wait to do that for just a moment, because I think that leaving this in the form of dots will help me make my argument more clearly. The blue dots represent the supply curve. That is, at a price of 40 cents per loaf, we get 1 loaf of bread supplied per week, 2 loaves at 60 cents, 3 loaves at $1, and so forth. The blue dots represent the supply curve. Now, we've got these price-taking buyers and price-taking sellers. All of them are doing the best they can, subject to the price that they are given by the market. Let's find now the price at which an equilibrium obtains. Suppose, first of all, that we consider a price of $1 a loaf for bread. What would happen in that case? Well, with a price of $1 per loaf for bread, there are 3 loaves that bakers are willing and able to supply each week. The quantity supplied is 3 at a price of $1. At a price of $1, the quantity demanded, however, is 8 loaves per week. That is, buyers are willing and able to purchase 8 loaves of bread at a price of $1. The fact that there are more buyers than sellers, or the quantity demanded is greater than the quantity supplied at a price of $1, means that we have excess demand. We have excess demand, which is the difference between the quantity demanded and the quantity supplied at the price of $1. I'll label this with a little sign that says excess demand. Now, when there is excess demand, the bidding mechanism takes over. The bidding mechanism is the process by which unsatisfied buyers try to bid up the price of bread to guarantee that they get some. After all, we've got 8 loaves of bread demanded here and only 3 loaves of bread supplied. We've got 5 loaves of bread excess demand. That could be 5 people who aren't able to buy their loaf of bread at a price of $1 per loaf. Those 5 people are now going to offer sellers a higher price. They're going to bid the price of bread up to $1.10 or $1.20 or $1.50 or $2 a loaf. They'll continue bidding until either it's no longer worth it to bid higher prices or until enough bread becomes available that the shortage of bread is eliminated. Look, if the price of bread goes up to $1.50 per loaf, the quantity supplied increases to 4 loaves. Some baker has a reservation price of $1.50. That is, he offers his loaf of bread for sale as soon as the price goes up to $1.50. At the same time, when the price goes up to $1.50, we've had one of the buyers drop out. That is, there was one buyer who was willing to pay $1, but not $1.50. So the excess demand shrinks as the price rises because additional sellers enter the market and some of the buyers drop out of the market. Finally, when the price of bread rises all the way up to $2.10 a loaf, the quantity supplied is equal to the quantity demanded. Enough buyers have left the market and enough sellers have entered the market to give us an equality of quantity demanded and quantity supplied. At a price of $2.10 per loaf, the quantity demanded equals 5 loaves of bread per week, and the quantity supplied equals 5 loaves of bread per week. This means that we have a competitive equilibrium. Taking prices as given, the quantity demanded by buyers and the quantity supplied by sellers are equal at a price of $2.10 per week. And we get there by the bidding mechanism. Buyers who can't get bread at the lower price will bid up the price. And as buyers and sellers respond to the rising price, an equilibrium is established. The excess demand is eliminated as the quantity demanded falls and the quantity supplied increases with the rising price. Now, you can see the same analysis working from the other direction. Suppose we start with a high price for bread. Suppose $4 a loaf. What would happen in that case? At a price of $4 per loaf, the quantity demanded is going to be smaller, that is 2 loaves of bread per week. Because the price of bread is high, the quantity demanded will be much smaller. However, bakers are very excited about this high price, and the quantity supplied is quite high because a lot of bakers can cover their opportunity cost at that higher price, and there's a larger quantity supplied at $4 per loaf. That quantity in our example is 8 loaves of bread per week. Well, there you've got a problem because we've got an excess supply. That is, the quantity supplied is 8 loaves at $4 per loaf, and the quantity demanded is 2 loaves at $4 per loaf. We have an excess supply of 6 loaves of bread every week. Bread piles up unpurchased on the shelves. What's going to happen in that case? The bidding mechanism will operate from the other direction. In this case, sellers who are unable to move bread from their shelves will begin to put the bread on sale. They will lower their price. Some sellers will offer their bread for $3.50 a loaf, or $3, or $2.75, and the price will begin to fall. As competition through the bidding mechanism pushes down the price of bread, 2 things happen. First, additional buyers will enter the market. Notice when the price drops to $3 a loaf, we can sell 3 loaves of bread because 3 people are willing and able to purchase bread at that price. As the price drops down to $2.50 a loaf, the quantity demanded increases to 4 loaves of bread, and so forth. So additional buyers enter the market as the price falls. As the price falls from the supplier's perspective, things are getting less attractive. So at a price of $3 per loaf, we find that a seller or 2 may have left the market. The quantity supplied is down to 7 loaves of bread. And at a price of $2.50 per loaf, the quantity supplied drops even further to 6 loaves of bread. Finally, when the price is $2.10 per loaf, the quantity demanded is equal to the quantity supplied, and the excess supply has been eliminated, partly by bringing additional buyers into the market, and partly by reducing some of the oversupply by pushing some of the sellers out of the market, sellers who can't cover their opportunity costs as the price of bread falls. Well, what's the outcome? The outcome is we wind up with a stable situation. The price of bread is set at $2.10 per loaf. We call that the equilibrium price. Since the quantity supplied and the quantity demanded are equal, and they are both equal to 5 loaves at that price of $2.10, the bidding mechanism is going to just sit there and do nothing. There's no tendency for prices to change. There's no excess demand, so prices don't rise. There's no excess supply, so prices won't fall. When quantity supplied and quantity demanded are equal, we're in a stable situation, a competitive equilibrium. So when the price is $2.10, the quantity of bread traded will be equal to 5 loaves of bread per week. We can label this P star, $2.10. That's the price at which supply and demand are equal. And we can label this Q star, the quantity of bread that's traded at a price of $2.10. So there you have it, the stable outcome, the competitive equilibrium. The bidding mechanism takes us to the point where the quantity supplied and the quantity demanded are equal. And once we reach that point, there is no further tendency to change. In the next lecture, we'll look at factors that can shift the supply and demand curve, upset this equilibrium, and lead to a new equilibrium. But first, let's connect the dots and make this picture look like something that we might be more familiar with. Connect these dots, and they become the demand curve. Connect the blue dots, that is, allowing prices and quantities to vary continuously, and you get a supply curve. The competitive equilibrium is found at the place where the supply curve and the demand curve intersect. As in most economic graphs, the most interesting point is where the curves cross. And it's where the curves cross that we find the price and quantity where supply and demand are equal. And when quantity supplied and quantity demanded are equal at a particular price, there is no further tendency to change. This is what a competitive equilibrium looks like. And usually we will mark the price and quantity with lines down to the axis to show us the price and quantity at which the market has a stable outcome. The elasticity of demand is the responsiveness of the quantity demanded to changes in the price of the good. We've discussed how to calculate the elasticity of demand, and we've also discussed the relationship between elasticity of demand and total revenue. One question remains. What determines the elasticity of demand for a particular product? What determines whether the demand for a product is elastic, that is, very responsive to changes in the price of the product, or whether it's relatively inelastic, that is, a large change in the price of the product may not produce a sizable change in the quantity demanded? What's the difference between goods with elastic demand and goods with inelastic demand? The first and probably most important determinant of the elasticity of demand is the availability of close substitutes. Products that have a lot of close substitutes are likely to have more elastic demand. For example, if one airline decides to raise the price of its tickets, customers can switch to another airline and fly perhaps to the same destination. The availability of substitutes makes the demand for a particular airline ticket relatively elastic. The demand for a particular kind of soda might also be elastic. If one company raises the price of its soft drinks, customers may switch to another comparable drink. Elasticity of demand often follows from the availability of close substitutes. The more substitutes are available, the more elastic the demand for the product is likely to be. The more close substitutes, the more price responsive. Products that are inelastic in demand are likely to be those that have no close substitutes available, or few good close substitutes. For example, the demand for insulin to treat diabetes is usually viewed as inelastic. Whatever the price of insulin is, a diabetic is likely to pay it rather than do without, because there are no good substitutes. However, even insulin is not a perfectly inelastic good. As the price of diabetic treatment goes higher and higher, some people who suffer from diabetes may look to alternative ways of managing their condition. They may choose to exercise more rigorously or watch their diet more closely, as opposed to paying higher and higher prices for the medicine. It's difficult to come up with any product that's going to be completely unresponsive, any product that has no substitutes at all available. Even though you need gasoline to make your car go, it may be that if the price of gasoline gets high enough, you will stop driving your car altogether and use mass transportation, or walk, or simply make fewer trips. The point I'm trying to make is this. If there are few close substitutes available for a product, the demand for that product is likely to be unresponsive to changes in the price of the good. When there are few close substitutes, people have to buy that product, and their demand for the product is unresponsive or inelastic. On the other hand, the more close substitutes there are available, the more likely you are to get elastic demand, that is, highly price-responsive quantity demanded. The second determinant of the elasticity of demand is time. The more time you have during which to search for substitutes, the more likely your demand will be elastic. Suppose I'm building a house, and I think I need lumber for framing my house and finishing it. If the price of lumber goes way up, and I have to make a decision now, I'm likely to just swallow the extra cost and finish my house with lumber. But if I have 2 or 3 months to make a decision, 2 or 3 months to search for a substitute, then I'm more likely to hold out and look for a possible alternative. During those months, producers may convince me that steel framing is a very good substitute for lumber. As lumber prices rise, producers will begin to offer customers alternatives. Alternatives don't come online quickly, so the more time you have to get an alternative, the more likely you are to find an acceptable substitute, and the more price responsive your demand for lumber will be. That is, the more time you have for making a decision, the more likely you are to find a good substitute, and therefore the more price responsive your demand will be. The third determinant of the elasticity of demand is the percentage of your budget that is spent on the good in question. If you consider your elasticity of demand for bubble gum, your demand for bubble gum is probably relatively inelastic. That is, when the price of bubble gum goes up from 2 cents a piece to a nickel a piece, you probably don't change the quantity that you consume during a week. Your demand for bubble gum is inelastic because bubble gum is not a big percentage of your budget. You may not even look at the price tag when you purchase gumballs. On the other hand, if you consider your demand for housing, your housing cost is such a large percentage of your budget that if your apartment rent were to go up by 20%, you may have to look for another place to live or take in a roommate. Because housing occupies a large chunk of your budget, your quantity demanded will be responsive to a given percentage change in price. Well, as a quick summary then, your demand for a product is likely to be more elastic if there are close substitutes available, if you have lots of time over which to search for substitutes, and if the product in question occupies a big chunk of your budget, so that price changes really require you to make some kind of adjustment. On the other hand, your demand for a particular product is likely to be inelastic or non-price responsive if there are not good substitutes available, if you have to act quickly and don't have time to search for substitutes, and finally, if the good in question occupies a small chunk of your budget so that you don't have to change your behavior when the price changes. These three factors are likely to influence whether the demand for a product will be inelastic or elastic. And as you know, once you know which it is, you can say how a change in price will affect total revenue raised in that market. Inelastic demand means that lower prices shrink total revenue. Elastic demand means that lower prices increase total revenue. Spend all this time and energy studying elasticity of demand. It's mathematical, it's not immediately intuitive, it's difficult. What's the payoff to you? The payoff is, once you understand the concept of elasticity of demand and how to calculate it, you have a useful tool for predicting the relationship between the price of a product and the total revenue that you earn when you sell your product at that price. Let me give you an example. Have you ever wondered why airline tickets go on sale all the time and appendectomies never do? The answer is this. If airline company ABC puts their airline tickets on sale, they will attract a lot of customers. They'll attract customers from their competitors, and they will attract customers from people who didn't even plan to travel. A small change in the price of tickets brings in a lot of new customers for ABC Airlines. Their total revenue increases because the demand for their product is very price sensitive. On the other hand, the hospital doesn't put its appendectomies on sale because if they cut the price, they wouldn't bring in a lot of customers. People don't buy appendectomies because of the price. They buy them because they need them. And if the price changes, the number of customers that come into the hospital may not change at all. You lower the price of an appendectomy, and all you're going to do is reduce the total revenue that you earn from doing appendectomies. This goes back to an idea that we discussed. That is, the price sensitivity of demand. If demand is price sensitive, a small change in price brings in a lot of new customers and total revenue increases. On the other hand, if demand is not price sensitive, a big increase in the price of the product may not change your customer base at all. You may still sell just as many appendectomies and total revenue goes up when price goes up. The relationship between elasticity and total revenue is a good reason to learn about elasticity of demand. It's a payoff for learning that difficult concept. What I want to do now is show you in mathematical terms how elasticity of demand and total revenue are related. In order to do that, I'm going to start with a mathematics trick, and you can see this in the box next door. The mathematics trick is this. If you have the product of two numbers, A times B, and you want to know how they change, you can approximate the percentage change in the product, A times B, as equal to the percentage change in the first factor, A, plus the percentage change in the second factor, B. This is a good and very useful approximation that's used all the time in economics. Now, I can't prove this without doing some kind of heavy-duty calculus with logarithms, and you don't want to see me do that. So instead, what I'm going to do is show you in a picture how the proof might look. Suppose we have a diagram with A on the vertical axis and B on the horizontal axis. If you pick a combination of A and B and represent that with a point, the area that is seen in the diagram is the product of A times B. Now suppose you change that area by moving A and moving B. You can add to A by adding height to the box. When you add to B, you add width to the box. And if you look at those two areas, you can see the percentage change in A and the percentage change in B. All that's left out is the little piece up in the corner. But this lets you know that you can take on faith my assertion that the percentage change in the product is equal to the sum of the percentage changes in the component. Now, let's put that to work to understand how elasticity and total revenue are related. What is the formula for total revenue? Well, it's the price of the product times the quantity that a firm sells, P times Q. What's the percentage change in total revenue going to be? Well, the percentage change in total revenue is going to be equal to the percentage change in the price plus the percentage change in the quantity demanded. How do I know that? Well, I just used my math trick. I used P as one variable and Q as the other variable. Now, here's the question I want to ask. If I change the price of the product, we know that quantity demanded changes in the opposite direction. That is, the percentage change in price has the opposite sign from the percentage change in quantity demanded. We know that because the demand curve is downward sloping. When the price goes up, people are willing and able to buy less of the product. What I want to know is, which of these two effects dominates total revenue? Does the price effect dominate? In that case, total revenue and price will move in the same direction. Or does the quantity effect dominate? If it does, then price and total opposite directions. Let's do a little bit of math here, and we'll come up with a familiar expression. Let's suppose then that the percentage change in price plus the percentage change in quantity demanded adds up to a number that's greater than 0. And we're going to suppose that that happens when the price of the good goes up. Now, let's take this equation and mess around with it a little bit. Let's start by taking this term, percentage change in quantity, and moving it over to the other side of the inequality. Now, I got to be real careful with my signs here or I can get confused. I decided that the percentage change in price was positive and the percentage change in quantity demanded was negative. So since I'm moving it over to the other side of the inequality, the percentage change in quantity is now going to have a positive number. The numbers on both sides of the inequality are now positive numbers. And the inequality tells me that the price effect, the percentage change in price, is bigger than the percentage change in quantity demanded. Now, divide both sides by the percentage change in the price of the product. And that gives you this fraction being less than 1. Now, does that fraction look familiar to you? Have you seen it before? You have. You have seen it before. That's the formula for the price elasticity of demand, the percentage change in quantity that results from a percentage change in price. That negative sign that we wound up with outside of that fraction, that does the same job that the absolute value sign did before. It just makes sure that the top and the bottom of that fraction have the same sign. That makes this a positive number. That's the formula for the elasticity of demand. And if it's less than 1, we say that the demand for this product is inelastic, like the demand for appendectomies. If that's the case, then price and total revenue move in the same direction. The company that has a product that has inelastic demand, when they raise the price of their product, what's going to happen to total revenue? It's going to go up. And why is it going to go up? Because the company is not going to lose customers. The customers are price insensitive. They stay with this firm even though the firm is charging a higher price. And because the price effect dominates the quantity effect, total revenue increases. Now, the opposite is going to be the case if we decide that the quantity effect is greater. If the quantity effect is greater, then total revenue is going to move in the opposite direction of the change in price. Again, the intuition is this. The firm may try to raise their revenue by charging a higher price, but what happens? What happens is all those price-sensitive customers defect. They go and buy some other product, some substitute product, or they just stay home. Because the quantity effect is so big, because this firm loses so many customers at the higher price, total revenue actually shrinks. And if you manipulate my equations, like I did before, you'll see that the measure of elasticity in that case is greater than 1. That is our definition of a good whose demand is elastic.